Good morning. How are you? Welcome to Spring One. Welcome to the Cloud Native Platforms track. I'm going to be your MC for the morning today, and I hope you've had a wonderful morning so far. We've got a great track for you, and we really look forward to giving you guys a phenomenal show here. We're going to begin with one of the uh, top, one great person from the Spring community, somebody who's going to talk to you today about inner loop development with Spring Boot on Kubernetes. And really looking forward to this one. Dave Syer is one of the founders of many of the technologies you probably use if you're a regular Spring user, Spring Cloud, Spring Boot, Spring Batch. Also a lead on the Spring Security OAuth team, and is an active contributor to Spring integration, Spring Framework, Spring AMQP, Spring Security. Generally, a very important person in Spring. He's an experienced delivery-focused architect and development manager, has designed and built successful enterprise software solutions using Spring and implemented them in all kinds of companies and institutions worldwide. And so without further ado, ladies and gentlemen, Dave Syer.
Thank you, and welcome everybody. I've been introduced. My name's Dave. Let's get started. So we're here to look at some Spring Boot concerns and mixing it all up with Kubernetes. So I'm going to share my screen like that, so that you can see roughly what we're going to be talking about. I don't have slides, it's basically a demo, but I'm going to walk through this repo on GitHub. But before we start that, let's just have a look at some housekeeping stuff. This is the first track in the first session, so you might not know a few things about what you can do and see at Spring One. I found out yesterday that there's a Slack room that you can visit. So if you haven't been there, this is it. There is actually a Slack channel devoted to this presentation, and I can see there are a few people there already waving. So hi, everybody. Feel free to ask questions there. I probably won't have time to answer them, but other people might be able to jump in until afterwards. After the talk, there will be a Q&A session in a separate Zoom room, and you will get a link to that if you haven't got it already. If you need help finding the Slack channel, I found it on the main Spring One website here. There's an FAQ page with a section on Slack, so that's how you can find it if you need to. So the presentation, the demo is, it's about the inner loop, and I'll explain what that means with Spring Boot and Kubernetes. I assume that everybody knows what Spring Boot is, and everybody knows what Kubernetes is, even if maybe you're not completely familiar with it. So we'll dig into both of those things, but I will explain what I mean by inner loop. If you want to refer to this, here is the GitHub coordinates. You could click into this and work through it on your own at some point if you need to. Everything you need to run the demo is here, and this is the README. So we're going to be talking about the inner loop, and by implication, there is an outer loop, but I'm not going to talk about that today. I'm not going to explain. I'm not going to give any demos on the outer loop. I'll explain what the difference is. We'll look at how to get set up to do this walkthrough. So we'll run a sample app, which is a very simple, download it from start.spring.io Spring Boot application. We'll look at some ways to improve the feedback cycle, so making it run, make a change and make it run faster. We'll build it into a container, deploy it to Kubernetes, and then we'll start looking at this sort of new, I guess, mini industry of inner loop tools. So there's quite a lot of people active in this field right now because it is a problem, right? When you when you're actively developing an application, you want to be able to make a change to your code and then see it happen, see it wiggling in the cluster, so see it running as quickly as possible. And typically when you're doing that these days, you're building a small part of a larger system, so you want to also have it, interacting with the other components in the same system, in that distributed system. You want all that to happen as quickly as possible. So I'm not going to exhaustively show you all the features of all the tools. I'm just going to pick a few. The first one I'm going to show you is Scaffold, which is my personal favorite, but it isn't exclusively the best or anything. Everybody has their own preference. I'm also going to show you Telepresence from the Ambassador people, and I'm going to show you Tilt. And there are other options out there. I could mention a few, but I won't. The other thing I'm going to do today is sort of a bonus section in this presentation, this demo, that isn't in the README, which is to show you some new stuff that is coming out of the VMware Tansy team right now. I mean, basically on the Launchpad, I think if you were in beta programs with VMware Tansy, you'd be able to get your hands on some of that stuff. So none of what I'm going to show you is in the Tansy box is specific to any of the other tools on here, Scaffold, Telepresence, Tilt, but I am going to show you it using Tilt. So that'll be at the end anyway. So moving on, the inner loop term. So I don't think we made it up. I think we have used it a lot internally now. So it's become part of the sort of day-to-day language, I guess, the domain language of the Tansy team. So we refer to inner loop and outer loop as being sort of dev time and promoting to production, basically. So at dev time, you want to make a small change and you want to see it wiggle. Ideally, you want to be able to debug what you've done, and you need to be able to iterate fast. So you want to be able to do that in a tight loop. And the opposite thing is the outer loop. You don't care so much about it being fast, but you do want it to be automated, reproducible, immutable, those sorts of things. And so you end up talking about continuous deployment and possibly also testing in production. It's kind of a trendy topic these days. One thing that actually occurred to me when I was thinking about this, preparing for the talk, there's sort of with the inner loop, there's sort of an interesting analogy here with Spring itself, right? Because as you know, Spring was invented and still serves to basically reduce the amount of boilerplate code, right? So that before Spring, you used to write a lot of code, and Spring, and especially Spring Boot, has shrunk that down to the point where you sort of do it by convention, and you don't have to do as much with the stuff you don't care about. So you write your business logic, and Spring does the rest for you. That's kind of the motto. And with the inner loop, the boilerplate is more of a sort of a process boilerplate, right? You want to reduce the amount of time that you sit there waiting for compilers and Kubernetes deployments and network configurations and all of that stuff that you don't really care about. It isn't getting your app code running. It's just fluff, basically, and you want that boilerplate to go away. So it's a bit like an analogy with Spring, and I think the team that's working on this stuff at VMware now is an interesting mix of Spring and other people, right? So the Kubernetes community, the DevOps community, the Spring community, everybody in the business unit at VMware is collaborating on this, and those kind of ideas are floating around, and it's a very productive environment. So I'm very happy to be working there at the minute. You will be able to see, so that the Tansy bits that I'm going to show you later on, you'll be able to see them in the keynote tomorrow. So they put me on before that, but I think if you look out for it, you'll find several presentations at this conference that are all about this kind of topic. So if you did look for keywords like Tanzu and developer experience, for instance, you'll probably see quite a lot of interesting stuff that's along the same lines. Anyway, so if you wanted to do this yourself, or you wanted to follow along, I'm going to switch to the IDE now. So I've got this same README here. I've just cloned that repo from GitHub, and I'm reading the README in the preview in VS Code. So there are some tools that I'm using. So you will need to do this demo, you'll need kube control, kubectl, however you want to say it. Oops, switched into the source code there quickly, sorry. Customize, optionally, I use that in one example. Scaffold, tally presence, and tilt. Those are the sort of inner loop tools that they're not exclusively inner loop tools. I suppose I should quickly say that they can be used and sort of basically to support any kind of continuous deployment, continuous integration process. But I'm going to be showing you the inner loop features. We're doing it on a local cluster, so we're using Kind. You could also use Minikube, you could use a remote cluster, whatever you like, however you like to set up Kubernetes. But if you do want to use Kind, there is a shell script here in the repo that you can use to set the cluster up. If you are able to use Nix, which I highly recommend because I like it, you can actually install all of that stuff like this. You just type Nix shell, and it installs the specific versions of all those software. So it's like having your own sort of environment, immutable environment for development. I like that. Right, so we've got an app. It's, like I said, it's a very simple Spring Boot app. I may do a version of this in the future that has, I don't know, a database, or I may do a pet clinic example, for instance. But at the minute, it's a very simple app. It's just a Spring Boot application with a single web endpoint that says hello. So if I was to run that using the command line, for instance, I could do Maven Spring Boot run. And it will start up in a couple of seconds, and then I could, let me use curl to test it, curl localhost 8080. And it says hello Spring, pling, brilliant, okay. So to give you a flavor of what we're going to be doing, if I was to make a change to that application, put an extra exclamation mark in, it would be nice, wouldn't it, if something happened here, and it doesn't. So I'm still looking at the old code. And so the whole point of the inner loop is to make this process faster, right? Make a change, see it happen, make a change, see it happen. So you probably know what the punchline is here if you've been using Spring Boot for a while, but Spring Boot DevTools, in case you haven't seen it, is going to be an essential part of the solution to that problem, or the recipe that I'm using, at least anyway. So it's a Spring Boot feature which watches your code for changes and restarts the app. What it does is it separates the class loader in the Java virtual machine into a layer that only has your code in it and a layer that has everything else. So the stuff that only has your code in it is relatively small and can be restarted very fast. And so that's what we're doing, basically restarting Spring, but not reloading or importing all of the class data from the JDK, from the class path libraries. So to do that, you would need to add a dependency. And so in Maven, you would do it like this. In Gradle, there's a similar idiom. It's a one-liner in Gradle, which Gradle people are very proud of, but anyway, here it is. It's a dependency, and it's a Spring Framework, Spring Boot dependency. Oops, double-clicked on it again by mistake. I'm sorry, to learn not to do that. The Spring Boot DevTools, and I put it in the scope runtime, just so that it's available at runtime, but I don't accidentally compile against it. And then what I've done in the demo actually is I've put that in a Maven profile. So if I go back to my app here, stop it, and then run it again with -p devtools, then that will activate that extra dependency. And yeah, there isn't much difference. The one difference that you'll notice is that the thread name here in the logs is now restarted main, whereas before it was just main. Can you see? So that's going to be important. That'll be the signal to us that we've got this right, basically, and whenever we're doing this remotely, which we are going to be doing in a minute. Restarted main means that Spring Boot is watching this application. So at the minute, I am now looking at the 2 exclamation marks version. There we go, 2 exclamation marks. And if I changed it to a question mark, watch what happens here. Save it. The IDE, I saved it. The IDE compiles the code, sticks it in the directory where it sticks things. Spring Boot then detected that and restarted it. Did you see that? There's the restarted app. And so when I curl it again, I get the question mark. Okay, so that was fast because we have this special class loader in the DevTools. And that's the key to this whole experience. So I'm going to stop that, go back to my script. So this thread ID is, whoops, I keep double clicking on it. I've got to learn not to do that, haven't I? This thread name is the signature that we're looking forward to, that we got it right. Okay, so now let's move from local development to cluster deployment. So the first thing we're going to want to do is build a container. And so to do that, we're going to use the Spring Boot tooling. Use Maven to create a container. It's still running tests. Finish the tests. Now it's downloading a builder. Okay, so I'm doing this using build packs. Paquito build packs is the group of build packs that essentially VMware manages. It's open source, but we stick them in this Paquito organization in GitHub. It's slow the first time. If I'd done this, I think they must have actually changed the builder base since the last time I ran this. It does change actually quite often because things get fixed and new features get added all the time. Because I just did this morning and I was expecting this to be faster, but it's okay, it's fine. It's only going to happen once, I think, while it downloads. So we're building an image. It's going to be a Docker image that has basically, I don't have a Docker file here, right? There's no input from me, the developer, into how that image is built. If I wanted to, I could control it. I could add some configuration to this build command so that it would use a different image to build. I could create a builder and I could upload it to a Docker registry, and then I could refer to it in the configuration for the build command here. But I'm lazy and I like to take the defaults. Somebody else has thought about that problem quite hard, so I'm quite happy to take the solution. So that's the value of using build packs. And this isn't the only way to build a Docker image, but it's my favorite because it falls out quite quickly. Basically, I don't have to think about it. Like I said, somebody else has solved all of these nice problems. Looks like I have a slow network today. It's probably because I'm running Zoom at the same time, isn't it? Let's see if we've got any questions in Slack. Somebody posted the link. That's a good idea. Oh, right. Yeah, Octatree. Yeah, I use that a lot. I like it. Thanks, Scott, for answering questions. There's somebody there who's helping. Thank you very much. The rest of it should go quickly, I think. Let's have a look at the structure of this project while we're here. It's just a Spring Boot app, some dot files. The Nix configuration is what I use to import the tools. There's a setup script for the kind cluster. There's your Maven stuff. And then there's actually evidence here that I've been using telepresence, although there's no local configuration for that. And then there's a config file for scaffold and a config file for tilt. Okay, it's finished. So it successfully built an image and it pushed it to a local Docker registry. So I'm not using Docker Hub or Google containers or anything like that. It's localhost 5000. So I'm running that as a Docker image as well. So that I run that, that means that I can now run the image itself. So here's Docker run, and I'm going to forward port 8080 to localhost. And there we go, that's the same app running, but you'll notice that it's running with the not DevTools, so it's running in the main. So I'll just prove that it's working, and it's the question mark. So it's the most recent version. So to run it in a container with DevTools, I would actually need to change the build so that it actually included that DevTools dependency. Might have been better if I'd done that the first time. Shouldn't take too long now that we've actually got that base image. There we go, 100%. Quick, okay, fine. So then when I run it, oh, it didn't work. I've still got the main thread, not the restarted main. So I made a mistake. The reason it doesn't is because you also need this. All right. So you need a system property that says, DevTools, I really want you. I know you're there. So the reason that isn't the default is because Spring Boot kind of assumes that if you're running a container, then you are in production. So it thinks that you don't want DevTools. So you have to switch it back on again. So there's a system property for that. Now I'm running with restarted main. And so when I go here, I'll get the question marks. But if I was to change it back to a single exclamation mark, you would see in that terminal there, you would see it restart. Actually, it's already done it too quick. And it's, oh, no, it hasn't. It hasn't because I'm stupid. And it's not supposed to happen, right? This is the problem with with running locally in Docker. Who's going to notice the change and copy it into that running container? All right. So nobody's doing that for me at the minute. So nobody's actually restarting this application. I might have assumed that it was going to just work, but of course it doesn't. So writing my own demo here. So it would be nice if you could get somebody to notice the changes that you made to the file system when you did a compilation there, where the IDE did the compilation, and then copy them into the running container, and then DevTools would notice it and restart the app. You could actually do that with Docker. You could do that if you could use, SCP or something, Docker copy. You could Docker copy the files from your host machine into the container. That would work, all right? I'm not going to show that because there are some, I want to get to the Kubernetes part, and there are some tools for Kubernetes that already do that for you. So the first one I'm going to show you is Scaffold. And Scaffold is a generic build automation tool for Kubernetes, but I'm going to show you the specific features that relate to this in a loop. So there's a scaffold.yaml here in this directory here. It doesn't have very much in it. Really, it just says the image that you want to run, the way that you want to build the image, because Scaffold will drive that process for you. You could use Spring Boot build image, or you could use Scaffold has native support. Double clicked again by mistake. I'm sorry. Scaffold has support for build packs natively, so I can just say what the builder is. And then I can make sure that it gets built with Maven with the right profile there, DevTools profile. So to make that work, I just need to do this, scaffold dev. Scaffold dev means run in development mode, and -- port forward means set me up a port on localhost so I don't have to mess around with finding my pod when it's running on Kubernetes. So it's doing that. It's already found the image because I just built it with Maven, I guess. So there it's deployed. It's already started, and you can see that magic restarted main thing, right? It's port forwarding a service, hello world. So let's have a look at what we've done. We have some, let's look at the full file, scaffold.yaml. So I've got a deployment section here which says use customize on this path, source Kate's demo, and source Kate's demo has a deployment essentially. So it's going to have a Kubernetes deployment with that magic Spring DevTools restart enabled true set in the environment, and a service which exposes that application on port 80. So it's running, and let's just make sure that it's running. Well, so it's not 8080 anymore. Scaffold by default uses, I think it said 4053, didn't it? 4503. I'm sorry, 4503. Right. So I've got my one exclamation mark version. Let's just do what we do: make our change, save it, compiles. Scaffold noticed that file was changed, and it copied it. Okay, syncing one file, it says. Spring Boot noticed that it had now changed in the cluster, in the deployment in the cluster, and it restarted the application. So now I will see 2 exclamation marks in my output. So that's a very fast turnaround from code change to wiggling in an actual Kubernetes cluster. It is actually in the cluster. Let me just demonstrate that. Get all. This is my deployment. This is my service listening on port 80, cluster IP. Oh, sorry, this is my service listening on port 80. There we go, port 80. And there's the pod. I could poke around in the IDE here as well. There's some nice stuff here. Workloads, pods, for instance. I could look at the Hello World pod. I would see all the stuff that Kubernetes has added to my pod declaration, but essentially the stuff that I set was this spec, right? Okay, great. So that's scaffold. And one nice thing about, there's a couple of nice things about scaffold. I'll just skip over the next section. So another thing you can do with scaffold is you can debug. Actually, maybe I'll show that because it's neat. So the first thing I'll do is I'll stop scaffold by just interrupting it. And a nice thing about that is it cleans up after itself. So it has left my cluster essentially empty. So I've got a terminating pod. So that's a nice experience. It just gets rid of everything it created. To show you the debug, it's a nice thing to do actually. So I said this is one of my sort of touch points for developer experience and in a loop. I like to be able to debug things if possible. So scaffold debug, I have to add -- autosync because it won't do that by default in debug mode. But you can make it just by adding that on the command line. So it deploys the same app in the same way, restarts it fairly quickly. And the main difference you see now is there's another port, 5005, which is the port that it's listening to for the debugger. And so I could go here in my Kubernetes workspace plugin thing from the IDE, and I can attach a debugger. I could do this with any IDE or manually, I suppose. Yeah, we like that. Maybe incompatible. No, I don't think so. Could be that this isn't going to work. I did it yesterday and it was fine, but I might have changed something. Not found. Huh. Oh, because I restarted the app, didn't I? I just need to restart. That's stupid. Refresh that view. Okay, we're in business now. So I'm doing Java debugging, and it's not 50,005, it's 5,005. Here we go. So here's my debugger running. And I guess I can prove it's running. I could put a breakpoint there, and when I do my little curl test, curl 4503, because that's where it's exposed, and it stops. Can you see that? So it stops, and I can play, and it sends me the result. How nice. Okay, so that was the end of the scaffold section, basically. So there's loads of features in scaffold. I've skipped over almost all of them. But I just showed you how to basically get things working, cranking the handle, making changes and restarting quickly. So another approach, actually, which doesn't, it's sort of almost the opposite. It doesn't involve copying resources into live containers, is telepresence. Oops, I double-clicked again. I have to learn to not do that. Telepresence. I'm going to show you version 2 of telepresence. You might find that if you wanted to try this out, your base distribution of Mac or Ubuntu or whatever might be giving you the older telepresence 1.0. So this is 2.x because it's kind of slicker. So if you have that, let's just make sure that we have pushed our image that we just built into the local registry. Then we will, in this time, we'll explicitly take control of deploying the application into Kubernetes. So it's the same thing that Scaffold was doing, but I'm going to do it manually now. Create a service, and then I will tell telepresence to connect to my cluster, for which it will need root access. And it's connected. Okay, so the thing that telepresence does is basically it sets up a bunch of tunnels and proxies so that I can run the app on the host, and the traffic that comes from the cluster gets passed into the host, if you see what I mean. So to do that, I have to tell it which thing to intercept. So I'm going to say you want to intercept the Hello World service on port 8080. And when I've done that, it will tell me that it's been successful. And it will look like this. Hopefully, there we go, yeah. So now anything running locally on port 8080 will be accessible in the cluster, as if it was in the cluster. So anything which is trying to access my Hello World service will actually be coming to my laptop, not to the cluster. And you can do this with any cluster. It doesn't have to be a local one. It could be a remote one, which is why it's so neat. And it also sets up this convenient DNS setting so that instead of doing port forwards, you can just curl hello world dot default, and that will go to the application in the cluster. The application in the cluster at the minute is not running, right? It's empty because I'm not running anything on port 80 on this machine. So I'm going to do that now. Go into my demo application. I'm going to debug in the IDE. So now I could have done this on the command line with Maven like I did at the beginning as well, but I'm running the main method. And now if I was to do that same thing again, whoops, what happened there? Oh, I just made another window. Okay, I guess I'll keep that then. I don't know how to get out of that. Okay, curl hello world defaults. There we go. Now it stops because I'm debugging, you see. So I can have the same experience developing the application. It's all running locally. I can debug it. I can do anything I want. I can look at the JVM. I can dump threads. I can do everything I could do with a local JVM because it is a local JVM, but the traffic is coming from the cluster. So press play and it'll come back with two exclamation marks. If I make a change it won't restart because I just used the IDE to debug. I didn't actually set up the dev tools to work because I'm not using that profile by default in the IDE. But I could do, right? There's no reason that wouldn't work. Okay, so that is a quick tour of telepresence. There's a lot more to telepresence than just that feature, but that's kind of the thing that's relevant to the inner loop. So then to finish it, you can leave that hello world service. Oops, I need to do it in here, not in there, because telepresence isn't installed in that other shell. That's the effect of Nick's shell, basically. And then I can uninstall everything and telepresence will clean up after itself. Brilliant. Okay, so there is, I think, telepresence 0.1. Look, there's a section here on that. So I won't go into that in any detail at all because I want to get to the other stuff. But it's there just in case you pick up telepresence, like from, you know, apt get install or something, and you end up with an older version. So which brings us to, see if I can get rid of this. Can I? Yes, good. No, I can't. Oh no. I just want to get rid of this window. You think I could just drag it away? It doesn't matter, I don't need that. Okay, fine. So Tilt is another tool that does similar things. I seem to be still running my app, so let's just switch that off. There we go. Tilt is another tool that does a similar thing, a similar set of features. A bunch of people at VMware really like Tilt, so I took a look at it because of that, and I do like it. It's got some really nice features. It's also got a very interesting architecture. You can ask me about that in the Q&A afterwards if you want to. Yeah, so you can think of it, for the purposes of this demo, you can think of it as, it's like Scaffold, but the config file is Python. Okay, so that's my simple-minded way of thinking about it, at least anyway. So this is my Tilt file. I have a custom build that creates an image in the same place. And to do that, it runs Maven Spring Boot build image. And then it says, I want you to watch the source files, essentially, and also the compiled files, target classes. And if any of those changes, this is a live update, I want you to copy files that change from target classes into workspace boot inf classes. And that's the location that the build pack puts the compiled classes from my application. Then I have to tell it how to deploy the app into Kubernetes. So that's the Kubernetes YAML. And I have to tell it which Kubernetes resource is being created. So it's a service called Hello World, and I want it to port forward 8080 to 8080. Okay, so let me just make sure that works. Tilt up is what you do. And it invites me to stream the logs, so I'm streaming the logs. There's also a web UI. I think there's a web UI for both telepresence. Maybe not Scaffold. There's definitely one for telepresence, so you can do similar, you know, graphical user interface things with all of these tools as well. Most of these tools. We're seeing the build take place again. This is just a Spring Boot build, like I did at the beginning. And it seems to be downloading a JDK kind of unnecessarily, but we'll get there. Still got 10 minutes, I think that's fine. So yeah, we could look at the UI, I suppose, the web UI. Where is it? I think it told me where it was, but it's scrolled off. Here it is. Here it is. Okay, so space to open. Okay, so I have to. Yeah, okay. I think I know the port. It's doing the build, it's working its way through. So localhost 3105, isn't it? Or is it 30? No, 31080. Let's try that. No. Okay. Does anybody know the tilt port? Pretty sure it's in that range somewhere. I don't use it much. It's a nice UI. You can see all of the Kubernetes resources in there, but I can see them here. So I tend to sort of reach for this IDE when I'm doing this local development thing. It's doing a build again for some reason. Which I think is something to do with a circular dependency in my custom build. I've been told that I need to fix that, but I haven't got around to it. It's fixable, is the point. So yeah, it is actually already deployed. Here we go. Right, so we're running, and we have restarted main. So we believe that we're probably going to be able to restart if we've got these syncs set up correctly. So let's test it. So with our curl command again, curl local host 8080. So that's 8080, but it's not running locally. Remember, that's just a port forward into the Kubernetes cluster. I'm getting 2 exclamation marks. Change it to a question mark. Watch what happens in the tilt window when I save it. Okay, so it noticed the change, it copied it over, and Spring Boot restarted. So I believe when I start here again, then I will get question marks. Okay, so it's all nice and fast, and it builds quickly. Brilliant. So that's tilt. You just do tilt up, and you get. I will show you the UI because it's kind of neat. Space to open the browser. There we go. 10351. I could have guessed that, couldn't I? Yeah. So basically, if you had a bigger cluster, you would see a box with all of the resources in there, and this Hello World one, it's basically the logs that I was streaming in the terminal. You can see those. You can see the URL that it's exposed on, that it's forwarded to, that you can view in the browser. You can see basically a view into the Kubernetes cluster, which is nice. Okay, so I'm going to kill that, and I'm going to do tilt down, which will also delete the stuff that it created. So when I look again at kubectl, everything's gone. Okay, so that's the sort of the main demo, and then the bonus section comes from. I'm going to switch windows. Another application. I've got another application which is very similar. It's just a simple REST controller with a different greeting, but it's basically the same application. And then I've got a tilt file, which is different. So the custom build is now, it's not using the local repository, but that's not registry, but that's not really all that relevant. Instead of using Spring Boot directly, it's using Tanzu apps, Tanzu CLI. So it's saying Tanzu apps workload. This workload is defined in a config file. And so the reason I want to show you this is because this is all of the YAML that you need to deploy a Spring Boot web application. Okay, so it's just, you need to tell it that you've got a workload, you need to give it a name, and you need to tell it what image to run, basically. There isn't much else. Actually, there is in this case, because I'm going to build the application in the cluster. I don't have to do this, but I've chosen to do it for this demo. I'm going to build the application in the cluster, and I'm going to build it from source code, which is in itself in a container image. And so there's a Tanzu component that actually makes that happen, that actually takes the local source code and builds it into a, actually not local source code, takes the source code from a Git repository and turns it into a bundle which is a container image, and then the build service can use it in the cluster. So there's a bunch of stuff in this is a different cluster. There's a bunch of stuff in this cluster that isn't in the old cluster. If I do get all, you won't see, you do see some different things. Oh, because it's already running. Okay, so I've already done tilt up here. So you have got here running this this controller, this application, which is being driven from this custom build. So it's saying, deploy that workload. Basically, it's saying, take my code and with a small amount of YAML, literally 10 lines of YAML, do everything you need to do. So build it, work out that it's a Spring Boot application, add a bunch of configuration to that, including the DevTools switch, environment switch that I had to add manually in the Kubernetes case. So there's something running in the cluster that will enhance my Spring Boot application configuration with things it thinks I need. I'm quite happy for it to do that because I don't really know about them. I just really want it to run. So this is kind of the Tanzu workload approach. It's called the developer experience for Tanzu. We call it a workload, and there will be different kinds of workload. This one is basically as simple as it can be, and the thing that builds the app in the cluster is going, just like a build pack does, it's going to, and just like Cloud Foundry used to do, it's going to recognize that it was a Spring Boot application and do a bunch of things to make it work. So that's what's neat about it. Okay, so I can make sure that this is working. So tilt is running, which means that I should be able to curl it, localhost 8080. Is it 8080? Maybe it's not 8080. Oh no, it's not, right, because it's this thing here. Look, yes, because I'm running the output of this build is not just a simple deployment and service like I had in the first demo. It's a Knative service. And for those of you who don't know what Knative is, it's a cloud CNCF project which basically enhances the service deployment model in Kubernetes to, for instance, take advantage of the fact that you might want to deploy multiple versions of the same application. So this is version 0001. So it's kind of a revision. This is called a revision. So Knative has revisions. It has roots. So this is an ingress. And so the feature I'm using here is it's a contour ingress. And so I can curl that thing, I believe, and I'll get my result. There we go. There's my greeting from the hello controller. If I switch back to tilt, and if I make a change to that code, go back to the question marks, load the question marks, save it, compiles, tilt noticed it, didn't do a complete rebuild, just copied the files. Okay, so that's what happened in the logs there. Yeah, it's scrolled off already. It recompiled and Spring Boot has restarted the application. So if I just curl again, I'm going to get all the question marks. So that basically shows the tight inner loop successfully running from Tanzu workload app. That's basically all I had to show. I will be taking questions. There's a Q&A session. I'm sure we're going to hear about that in a few seconds. So take yourself over there if you want to come and chat about it. I'll go through the Slack channel in case there's anything that's unanswered there. And thank you very much for coming. There's so much more that I could have shown you today. So if you want to see a bit more, or you want to poke my brain, ask me questions, come into the Q&A. Thanks very much. Over to you.
Thank you very much, Dave Syer. just amazing to see how the tooling in Spring is evolving. I remember the joy I had when I did Smalltalk development many years ago, and you could make a change and quickly push it out there and just iterate really rapidly on code. And to see that in the Java world on these complex distributed systems is absolutely fascinating. So with that, let me just remind you that there is a discussion going on in the Spring One Slack channel. There is a specific channel which is the word session, a dash, and then the name of the session with all dashes in between. But the easiest way to find it is to go to the session page for this session and click join the discussion there. And Dave will be hanging out in there for a while, I think, answering your questions and taking your comments. And so with that, thank you very much. And, look forward to seeing you in the next parts of the show. Thanks.